NASA is now on high alert after something completely unexpected happened. The interstellar object known as 3I Atlas suddenly slowed down by nearly 300%. Scientists say this is impossible for a natural object to do. In the empty space between planets, where there is no air resistance or gravity strong enough to cause drag, 3I Atlas should have continued moving at a constant speed. But instead, it's slowing down, as if something invisible is holding it back. This strange event has left experts asking one big question: not where it came from, but what could possibly be stopping it. When scientists first studied 3I Atlas, they noticed right away that it didn't behave like anything formed inside our solar system. It was traveling on a hyperbolic path, moving too fast to be captured by the sun's gravity, which means it came from another star system. Calculations showed that it didn't come from anywhere near us. When they traced its path backward through the galaxy, it didn't connect to any known star system. Instead, it appeared to come from the vast empty space between two major regions of the Milky Way, a quiet area where old stars drift in tilted orbits far from the galactic plane. That strange origin told scientists something important. 3I Atlas is ancient. It could have been traveling through space for millions or even billions of years without being disturbed by anything. The materials found on its surface support this theory. Observations from telescopes on Earth showed that the object contains carbon-based molecules and bright, reflective dust. These materials should have broken down long ago if they were exposed to radiation and cosmic rays. But somehow they're still preserved, suggesting that 3I Atlas spent most of its existence hidden from harmful radiation, possibly in the cold outer reaches of a long-gone star system. Its age also points to something even bigger. Based on its chemical makeup, 3I Atlas seems to have formed in an environment with very few heavy elements but plenty of frozen ices. That means it may have been created during the early days of the Milky Way, when the galaxy itself was still forming. In other words, this object could be a direct piece of the galaxy's early history, frozen, untouched, and preserved for billions of years. When scientists tried to track its journey back in time, they couldn't find any sign of a parent star. They tested 62 possible stellar encounters using data from the European Space Agency's Gaia mission, which maps the movements of stars with extreme precision. But none of them matched. This meant that 3I Atlas didn't recently break away from a star system. It's been drifting alone for so long that its home star might not even exist anymore. It may have died out billions of years ago, its light now just part of the faint background glow of our galaxy. Because of its path and speed, scientists think 3I Atlas comes from the space between the Milky Way's thin disk and thick disk. This area is known as a transitional zone, where old and young stars mix, and where objects can move freely for unimaginable lengths of time. It's a quiet place where cosmic encounters are rare, and gravity is weak. An icy body released there could travel undisturbed for eons, only passing near other systems by chance. Its movement and composition fit perfectly with that theory. 3I Atlas moves faster than most stars in the thin disk but slower than objects from the galactic halo, placing it right in the middle of that ancient region. Its low metallic content also matches stars that formed early in the galaxy's history, before heavier elements spread across space through generations of exploding stars. That makes 3I Atlas more than just a comet or asteroid. It's a relic from the dawn of the Milky Way, a frozen artifact from a time when the galaxy was still forming. It's a survivor, a messenger carrying the chemistry of an era long before our sun, Earth, or even our solar system existed. Now, as it passes through our solar system, something strange is happening. Its speed is dropping for reasons no one can explain. There's no known physical process that could slow it down this much in deep space. That means something new, something we don't yet understand, might be interacting with it. NASA and observatories around the world are watching closely, because this mysterious object may not just be an ancient fragment of the galaxy. It could be a clue to new forces or technologies beyond what we know. The thick disk of our galaxy is made up of ancient stars, some of the first ever formed during the Milky Way's chaotic early years. Back then, collisions with smaller galaxies and turbulent flows of gas shaped the galaxy's structure. Between this thick disk and the younger, thinner disk lies a quiet, cold space, a kind of gravitational buffer. In this still region, Fragments of ancient matter could drift for billions of years without being disturbed. The interstellar object known as 3I Atlas seems to move right through this hidden zone. Its orbit shows that it never moved with the rotation speed of younger stars in the thin disk, nor does it follow the strange, tilted paths typical of objects from the galactic halo. Instead, it travels in a rare and stable corridor, a place where ancient debris could survive long after its original star faded away. When scientists analyzed the light coming from 3I Atlas, they found chemical clues that matched this story. The ratios of carbon to oxygen, along with its low levels of heavy metals, perfectly matched the type of material expected from the early Milky Way, when stars had not yet enriched space with complex elements. This means 3I Atlas is likely made from the simplest kinds of interstellar ice and dust, raw material that hasn't changed since the galaxy was young. Inside its crust could be dust grains containing isotopes older than the Sun and possibly older than most planets in the Milky Way. The frozen molecules in it may have formed during the galaxy's first cooling period, when water, ammonia, and carbon monoxide began sticking together under faint starlight. As it travels through our solar system now, 3I Atlas carries the cold memory of that ancient time, a temperature record from when the universe was still young and quiet. When the James Webb Space Telescope observed 3I Atlas entering the inner solar system, it picked up something surprising. The telescope detected bright infrared light between wavelengths of 2 and 5 microns, showing that the object was releasing large amounts of carbon dioxide, far more than water vapor. For every molecule of water, there were nearly 8 of carbon dioxide. That's completely opposite to what we see in comets from our solar system, which usually release mostly water and only small traces of CO2. This means 3I Atlas must have formed in an extremely cold environment, much colder than the region where Earth and the other planets were born. The chemical signals from the James Webb Telescope also revealed something even more unusual. There were strong carbon dioxide emissions, but no signs of methane, a gas normally found with CO2 in comets. The surface of 3I Atlas seemed to be releasing gas from narrow vents rather than from the entire surface. This suggests it has a thick, insulating crust that has survived since it first formed billions of years ago. It's as if the comet has been sealed in ice for ages and is only now exhaling for the first time in eons. This composition fits perfectly with the idea that it came from a primitive region of the galaxy, a place poor in complex organics but rich in oxidized carbon, the kind of chemistry that would naturally produce a CO2-heavy body. To astronomers, 3I Atlas doesn't look like a normal comet at all. It looks like a frozen experiment left over from the early universe, a snapshot of the chemistry that existed before planets like Earth ever formed. Then, things became even stranger. Instruments aboard NASA's Swift Observatory detected faint ultraviolet emissions around 3085 angstroms, a wavelength linked to hydroxyl, a chemical fragment that comes from water molecules breaking apart in sunlight. This meant that 3I Atlas was releasing water vapor even though it was still far from the Sun, more than 3.5 times farther than Earth's orbit, where most comets remain frozen and inactive. This discovery confused scientists. If the comet's surface was dominated by carbon dioxide ice, then it should have been far too cold for water to evaporate. To explain this, researchers proposed two possibilities. Either 3I Atlas hides buried layers of water ice beneath its crust, with gas escaping through tiny cracks, or energy moves through it in a way that we don't yet understand. Both explanations challenge what we know about how comets behave. Further monitoring showed that the comet's brightness changed rhythmically, suggesting it was slowly spinning. Jets of vapor would burst from certain areas and then fade again, producing waves of gas that stretched for thousands of kilometers. Even though the gas release was not extreme, it was impressive for a comet so far from the Sun. The evidence suggests that 3I Atlas has a layered structure, with an ancient, carbon-rich crust on the outside and hidden pockets of water ice deep inside. When sunlight reaches one of these vents, it heats the trapped ice, causing pressure to build until the gas bursts out and then freezes again. This means 3I Atlas is not just a dead rock drifting through space. It's alive in a slow, rhythmic way. It breathes as it rotates, releasing gas and then going still again. It behaves like two objects combined into one. The outside is ancient and unchanged, while the inside still holds traces of fresh, primordial water. This makes it both a relic and a living record, a cosmic time capsule that shouldn't still be active, yet continues to whisper the chemistry of its mysterious birth. As it moved deeper into sunlight, radio telescopes on Earth began picking up a faint, repeating signal at 265 gigahertz. It was the unmistakable signature of hydrogen cyanide, a simple molecule, but one that plays a vital role in the chemistry of life.